Okay, good morning. Welcome back. This is Geography 10, Lecture 10. Today we're going to talk about the Arctic, a part of the world that otherwise doesn't get much attention this semester, but which is worth paying some attention to. This will also allow us to pick up some of the things that we just barely touched last time discussing Terra Preta about carbon and global warming. So we're going to talk about the Arctic and climate change, and then try to relate that to questions of sovereignty, property, and territoriality. In many ways, well, there's a depressing part of the story about the Arctic right now, and then there's sort of an exciting part, and the exciting part is the part in which the world is trying to figure out what the territoriality of the Arctic should be under the new circumstances in which suddenly we can attempt to exert property claims or have a reason to exert property claims there, and therefore also sovereignty claims. First, quick update. The reading for Tuesday is from your atlas, pages 32 to 41. We will spend lecture on Tuesday having a review session. As I said last time, please come to class on Tuesday with questions that you would like to hear answered or topics you would like to hear discussed further. At the beginning of class, I will take those questions from you and put them on the board, and we'll decide which ones to treat or which ones to treat first together, and then we'll discuss them, okay? Finally, the midterm will be on the following Tuesday, March 9th. We'd ask you to bring a blue book and a pen for the midterm. A black or a blue pen, please. I also think do we not need to ask some volunteers to go to 575 instead of here for the midterm? How many do we need? About 10? Okay, if you are a DSP student, you will take the midterm not in this room, but in room 575 in McCone Hall. That's the big seminar room at the end of the hall on the 5th floor. I also need to ask for roughly 10 volunteers who are not DSP students to volunteer to take the midterm in 575 McCone instead of here, so that we have enough seats in this room for everyone. Believe it or not, there will be a shortage of seats. So if you're willing to take your midterm exam in 575 McCone, please raise your hand now. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those 10, and you have to remember who you were. All right, I didn't get your names. Plus the DSP students, please go to 575 McCone at this time on Tuesday the 9th, okay? With a blue book and a pen. The midterm will look something like this. There will be essentially a map quiz built into the midterm, and it will cover North and Central America, and we will post those items and map to BSpace a week before the midterm. We will also take one of the reference maps, which is to say one of the maps we have already used for a map quiz, and we will reproduce it in the midterm, and then we will ask you a series of questions that will require that you still remember what you remembered when you took the map quiz, okay? So instead of asking you to put certain place names on dots or on countries on the map, we will ask you questions like, which two countries border such and such river? And you will have to look at the map, find the river, locate the countries, and remember what they're called, okay? That kind of thing. So that will be the first two sections of the midterm. Probably take, 10 minutes apiece. There will be a section of basically ID questions or definition type questions, questions where you can answer it almost by filling in a blank or by writing a single sentence. There will be a couple of short essay questions where you're asked to write maybe 1 or 2 paragraphs. And then there will be one longer essay question that will take, say, 4 or 5 paragraphs to answer. And for that one, I expect that there will be like 2 questions to choose from, and you'll get to choose to answer one of them. Any questions? Yeah. How many short essays will there be? Probably about 4 of them, something like that. Yeah. How will it be graded in terms of point distribution? Boy, I probably couldn't answer that precisely if I looked at an actual exam. Off the top of my head, I want to say that the 2 map quiz type things, the 2 first sections together, will probably be worth about 20%. Maybe 25. I guess when you get down, probably like 25% for the maps, and then maybe 15% for the IDs, and then that gives us a 40. Then I want to say probably 30% for each of these last 2 sections, something like that. There was another question I thought. Maybe it's already answered. Okay. Today, the reading for today was the last couple chapters from Crosby. And I'd be happy to discuss Crosby with you if you have questions or if anybody has sort of final thoughts about Crosby. Questions? Issues? Everyone feel like you've got it now? It all makes sense? It's clear? If you'd like, we can talk about Crosby now, but we don't have to if you don't have any questions. Because I think I've said most of what I had to say. Yeah? You sure? Is that your hand? No, it's not your hand. Okay. Well, then let's talk about the Arctic then. Your cat's on fire? What? Interesting. He must have just gotten an email or something. I'm pretty sure he said his cat's on fire. I bet he really doesn't like this subject. The Arctic. What's going on in the Arctic? The sea ice, well, right this second it's not melting, right? This is the cold time of year up there. Chances are it's in fact freezing right now. But the big trend is that it's melting. This is from very recently, just last month. Arctic sea ice extent, so the amount of the Arctic Sea at the North Pole that's covered in ice, is now lower than it was at this point during the record-breaking 2006-2007 cycle that resulted in the record lowest sea ice extent ever recorded in the summer of 2007. Well, the summers of both 2008 and 2009 saw extreme melting far in excess of average. Neither quite reached the extent of 2007. So what we're talking about here is that, here, I'll skip ahead and do the better one. Here's a graph of it, for example. On the left here, the extent of ice, millions of square kilometers, beginning in October, when it starts to expand, through February, the black line indicating the average amount of ice frozen at each date over the 1979 to 2000 period. The green dotted line is just the data for 2006, 2007, which by the end of the following summer was the smallest ever recorded amount of sea ice. And the blue line indicating what's going on this year. So where the sea ice is now, how much sea ice we have right this second. And you'll see that it was lower than that previous low when it started in October. It got a little bit ahead of it there in late November, fell back, and now it's basically on course, very similar and a little bit below what it was in 2006, 2007. The two pictures on the right, the minimum amount of ice in 1979, which is typically, it's about the end of August or the beginning of September when you have the least ice in the Arctic Sea. It's done the most melting, and then it starts getting cold again, and it stops melting back. So in 79, it looked like that. And in 2005, it looked like this. And you can see that instead of reaching all the way to the north part of Asia, Siberia, there's a huge open path of melted, thawed water, blue. And similarly, you can see more, but only slightly more perhaps, through the Northwest Passage above Canada. Now let's go back here. Why does this matter? Because there aren't enough places where you can wear your swimsuit and look at glaciers, and we're going to have more of them. It's going to be very exciting. The tourist opportunities are enormous. Actually, I'm not entirely kidding. But let's look at this more. Arctic to be ice-free in summer in 20 years. Here again, this is from very recent news reporting about scientific papers that have been published very recently. And one of the prominent climate scientists has predicted that in 20 years, there will be no ice in the Arctic Sea at the end of August, beginning of September. That's newsworthy because previously we thought it was going to take like 40 or 50 years or maybe even 100 years before we would get to that point. And now the expectation is, judging from the trend, that in fact we will see no ice in the Arctic by the middle of summer in as little as 20 years, according to this scientist. And from the article about this paper, sometimes referred to as the Earth's air conditioner, the Arctic Sea plays a vital role in the world's climate. As Arctic ice melts in summer, it exposes the darker colored ocean water, which absorbs sunlight instead of reflecting it, accelerating the effect of global warming. Are you all familiar with this process? What is this called? Anybody know the term, the scientific term that refers to this phenomenon? Albedo. The albedo effect. If the top of the Earth is covered in ice, which is very, very white, that ice reflects sunlight, the radiation from the sun, back into space, which reduces the overall amount of radiative forcing, radiation that the Earth is holding within its atmosphere. If, on the other hand, the ice melts and it's dark blue water, it does not reflect nearly as much radiation back into space as it did when it was ice. It, in fact, absorbs radiation and warms up, holding heat inside the atmosphere and raising the overall radiative forcing on Earth. So what this represents, potentially, is a positive feedback, which is not to say that it's a good thing. It's to say that it's self-reinforcing, right? The hotter the Earth gets, the more that ice will melt. The more the ice melts, the hotter the Earth will get. And we will see an acceleration in the effects of global warming as the Arctic sea ice cap melts. Anybody concerned about this? Is this one of the things you lie awake worrying about? Yeah? Yeah? Okay. So there are a couple of you. Maybe 3? Nobody else? You? Okay, we're up to about 4 or 5. Okay, we have a lot of work to do then, I guess, to persuade you to be concerned about this. What are some of the reasons we might be concerned about this? Yeah? It's adding more fresh water to the oceans, which can disrupt patterns, currents, and the movement of energy in the oceans. This is true. This is particularly a concern off the southern tip of Greenland and in the North Atlantic. And actually, we'll get to that in a few minutes. What else? I mean, some of you said you are concerned. Why are you concerned? What concerns you about this? This is a long way away from the cold. The Netherlands might be completely underwater. And parts of Florida. Okay. You remember that slide I showed of what the coastline of the southeastern United States looked like when in between ice ages, when the sea level was higher than it is now. There's a lot of what's now Florida that will be essentially part of the ocean. Yes? The difference in the sea level between lowest and highest amount of ice. Anybody remember from that slide? Which lecture was that? I think it's several hundred meters. Oh, no. Oh, I'm sorry. No, I thought you were talking over glacial, interglacial cycles. Every year, the amount of... good question. When the ice melts in the summer, how much does it raise sea level? Okay. Okay, very good. When the sea ice in the Arctic Ocean melts every summer, sea level worldwide rises none. Nil. It does not change. And the reason that is that all that ice is floating in the water anyway. So as it forms, it simply displaces water of equal weight. And as it melts, the water, it readjusts. So that doesn't change sea levels at all. It's only the ice that's on land, which, if it melts, will raise sea levels. And that is a significant concern. And here we're actually, when we talk about that, what we're really worried about in the North Pole is Greenland. And we'll talk about Greenland in a moment. Any other reasons why we might care about this? Yeah. The polar bears! Absolutely! We're talking about basically wiping out the polar bears. Or at least that's as best as we can figure. If there's no sea ice in the Arctic in the summertime, chances are that the polar bears will not make it. Or if they do, they will only make it by essentially retreating to land. And if they do that, the problem is all the land is getting warmer and warmer and warmer too, right? They may in fact find that the habitat conditions they need are simply not to be found. And the polar bears, in fact, have recently been petitioned for listing under the Endangered Species Act in the United States. I believe that petition was successful. Is that right? I don't know. The Fish and Wildlife Service this is the kind of thing that makes the Fish and Wildlife Service wish it didn't exist, right? This is the kind of decision that the science is overwhelmingly clear what they should do, but the political ramifications of actually doing it are absolutely unacceptable, right? Which is to say, if they list the polar bear, arguably the law will say that the government must take whatever steps are necessary to protect the polar bear from going extinct. And yet the only step that we think really will prevent the polar bear from going extinct is to stop burning fossil fuels. And let's face it, it's going to be hard getting that one through Congress, right? Congress is probably going to stand up and say, well, let's amend the Endangered Species Act and simply say somewhere in a paragraph, this doesn't apply to polar bears. I would predict that is what Congress would do if it were really forced at that kind of level of logical coherence, right? But actually, it probably just won't be. They'll probably come up with some plan to like airlift polar bears to Antarctica or something like that, so that we can save them that way instead. And that's only a little bit facetious when I say that. Why else would we care? Yeah. Okay. Storms, hurricanes are expected to become more intense under, as temperatures increase under global warming. That's a reason to care about global warming. It may or may not be specific to a reason to care about the Arctic. But I guess the final thing I would add is that one really good reason to care about the Arctic is that it is a magnificent early warning system for the rest of the world with respect to climate change. If you have doubts about climate change, the Arctic is a really good place to go and look and see whether you should believe this. Because according to the models, temperatures will rise much further and much faster in the Arctic than they will down around here. And this is, in fact, what we're seeing. To that extent, it's also a nice place to go and sort of imagine how much change could be brought by a simple ratcheting up of temperatures by, let's say 4 or 5 degrees, 5 or 6 degrees Fahrenheit. Doesn't sound like that much. It's already happened up there. So we can go and look. What else? So anyway, another map here. The yellow line depicting the average, the median sea ice extent in September from 1979 to 2002, and then the white in the picture depicting that late summer of 2007 when the sea ice reached its previous minimum. And you can see there that by that point, the Northwest Passage above North America was pretty much ice-free. And you could make it pretty much anywhere you wanted to go. There wasn't that much in your way in the way of ice. We talked about this already. Let's talk about Greenland for a moment. How much ice is on Greenland? Anybody know? There are a lot of different ways of measuring it. How thick is it? Anyone know, roughly? How thick is the sea ice, by the way? The sea ice, we'll actually see a picture of it here in a moment, but the sea ice in the Arctic Sea itself isn't that thick. Anywhere from a foot or two to maybe 6 or 10 feet thick. The ice on Greenland, who's got a guess? Yeah. 2,000 meters. That's in the ballpark. We're talking like between 1.5 miles and 2.5 miles thick. If all the ice on Greenland melted, sea level would rise worldwide by 16 feet. And that would be enough to put, say, Miami underwater and a lot of coastal populations. So we have a lot of reasons to worry about this, about that ice staying there. The map on the left is the pink on each of these maps indicates areas of melt from this colossal sheet of ice in 1992. And the pink on the right-hand map is the same, but for 2002. So we see in just a 10-year period an incredible increase in the amount of melting going on in Greenland in the summer. In the past decade, surface melting of glaciers around Greenland due to warm air temperatures has increased in both magnitude and area, while snowfall has increased just slightly. The result is a tripling in the amount of ice mass lost in Greenland between 1996 and 2007. We're talking about quantities of ice lost in the billions of tons. I'm sort of bouncing back and forth between the Arctic and Greenland here. Maybe I should order these slides slightly differently. Let's go back to the Arctic Sea for a moment. The graph here on the right, all of the dotted lines and the big red line were the projections made by the IPCC, the Intergovernmental Panel on Climate Change, when it sat down in, this must have been the 2002 IPCC? Not sure which one it is. Anyway, they predicted. They said this is how much we think we will lose sea ice in the Arctic in the next century. And all those different lines represent different models. And the red line is the average of all the models that they use to project this. And so you can see sort of roughly what we thought the range of possibilities was as far as the rate of sea ice loss in the Arctic. And the black line is what's actually happened. So you can see that in a very short period of time, the actual rate of loss of sea ice has already gone way outside what we thought might possibly happen under various scenarios and models of the IPCC. So this is just to say this is happening much more quickly than we anticipated. The map at the top depicts the relative portion of the Arctic sea ice that is new that year, that just froze that year, versus ice that froze 1 or 2 years ago, versus ice that froze more than 2 years ago. Which is simply to say how much of this ice is actually persisting all the way through the summer and remaining and then becoming a sort of basis on which more ice can form the following year. And the point is that compared to the average between 1981 and 2000, 2009 shows ice that even if it's there is almost entirely brand new ice that year, which is going to be much thinner and much more likely to melt than ice that is older than that, right? It's a way of depicting the fragility of the ice that's there, even if it appears to be covering the sea in significant measure. And then the lower graph simply charts this out over the period 81 to the present. The relative portions, you can see that whereas 1-year-old ice was only about 50% previously, it's now in the ballpark of 75% of all the ice at the maximum extent of freezing. Oh, now you can see a neat little movie. This is a way to get at that question of thickness. How thick is the ice over the course of a year? Here we are, it's September, late mid-September, so this is probably the minimum. Only the red spots are ice thicker than 6 meters or 5 meters roughly. So that would be what, about 15 to 20 feet thick. Most of the ice is in the ballpark of 3 meters, so that's maybe 10 feet, and you can watch this as it retreats, melts, contracts over the course of the summer. And again, we'll talk in a moment. The reason that a lot of people in the world are concerned about this, or rather actually there are a lot of people in the world who, believe it or not, are excited about this, and the reason for that is the possibilities of shipping. If you look